So far, our work is focused on things like properties of angles and lines and how they came together, and we made some equations for those. And then we looked at a lot of constructions. So now we want to turn our attention to triangles and some of the properties of triangles. So to get us started, let's remind ourselves of some basic facts about triangles. Okay, so some basic facts. What is a triangle? Well, we know a triangle is a three-sided polygon. Okay, we know it has three sides, three angles. We can name a triangle calling it triangle ABC. You could call it the same triangle, triangle BAC. It doesn't matter how you name the triangle. It's going to be the same triangle. Okay, now one thing we do know about triangles is the triangle sum conjecture. This is something you learned way back in elementary school, probably. You learned that the triangle sum conjecture, which basically says if you add up the three angles of a triangle, they sum to 180. So the angles of a triangle sum to 180 degrees. That's something that you've known for a while. So the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. That is old news. You've known that for a long time. Okay, so let's make another observation. Here's what I want you to do. Take a look at these triangles and solve for X and then solve for Y. And then I'm going to ask you these couple questions. Okay, give that a try. All right, so if we take these two, 43 and 81, so 43 plus 81 plus X has to equal 180. Well, 43 and 81 will give me 124. So when I subtract that on both sides, I'm going to get 56 degrees. Double check my arithmetic, but I'm pretty sure that's right. And over here, same thing's going to happen. So for X will equal 56 degrees and Y will equal 56 degrees. Now, I didn't solve for them both, but did you really need to? No, you didn't. Since both triangles had two corresponding congruent angles, it forced the third to be congruent. Okay? Since 281s, 243s, there's only one other number left to give me the 180 in both triangles. This is actually what we call the third angle conjecture. Okay, the third angle conjecture says that if two corresponding angles in two triangles are congruent, then the third corresponding angle, the third corresponding angle is also congruent. Now here, notice we're using this word corresponding again. That just means matching angles. So in these triangles, 81 degrees corresponds to 81 degrees. 43 degrees corresponds to 43 degrees. So X corresponds to Y. So that's what we mean by corresponding this point. It's not the same corresponding as corresponding angles in parallel lines. So that's why you got to be careful about using that term corresponding, because it just means matching angles. So either matching angles of parallel lines, or in this case, the matching angles of triangles. Okay, so that's kind of an obvious kind of a duh statement, but it is a very important statement that could help us. It saves us from doing some extra arithmetic. Okay, so now let's try a little investigation. Use your compass and straight edge and get these measurements. Now you could do this a couple ways. If you've got this printed out, you can actually get your measurements from the actual compass here. Or if you don't, you can go up and measure the screen right now. So I believe your compass will actually fit across this on the screen. Okay. So either print this out and try this on a separate sheet of paper, or copy these on the screen and try them on a sheet of paper. You're probably better off printing this out, although I did give this to you, you could open this up. So give that a try while we're on the pause. And when you're done, and you've got tried to do these 3 triangles, DOG, CAT, FSH, then we'll come back. Okay? Great. Give that a shot. Before you get going on this, just a little bit of information here I discovered as I was doing my work. You might want to actually get this first stretch by tracing it on paper. Okay, I found out that the compass doesn't actually, if you've got one of these, it doesn't reach the end. So take the longest line of each one, start there and trace it right into the middle of your paper. Okay, that way. Now I'm still going to use my straight edge to try to get a straight tracing, but trace that. Then use your compass to get the other 2 and make the triangle. Okay, go for it. So now that I did that, here's my first triangle, DOG. Not a problem. I trace DG as my compass for O. Yay, triangle DOG. That was no problem at all. But when I came to my next triangle, I ran into a problem. Trace CT, but when I did CA and AT, they didn't intersect. In fact, they're actually going to come together in the same spot right about here. If I kept going with my compass here, probably going to get these come together there. And if I continue with this one, pretty close. So basically, CA and AT almost add up to equal CT, but it doesn't make a triangle. So make that note, CA plus AT equals CT, but not a triangle. And when I came to the last one, it got even worse. I was able to trace to FS, but these don't even come together. FH plus HS ends up being less than FS. No triangle. So this leads us to some discovery about triangles and their lengths. Not any 3 sides makes a triangle. Turns out that the triangle inequality theorem tells us that any 2 sides of a triangle must sum to be greater than the 3rd side. Okay, so that means if I've got 3 sides of a triangle, for example, if I give you the sides of a triangle are 3, 8, and 15, will that make a triangle? Well, if I add 15 to any of those, it's obviously going to be bigger. But if I add 3 plus 8, that's only going to give me 11. And 11 is less than 15, so no triangle. If I gave you the sides 3, 4, and 5, well, 3 plus 4, the 2 smaller sides, are 7, which is greater than 5, so yes, triangle. Okay? If I gave you sides 2, 7, and 9, well, 2 plus 7 equals 9, which equals 9, so not a triangle. Can't equal the number, it has to be bigger than the number. Okay? That's what the triangle inequality theorem tells us. Now we can take that and spread it to another idea about triangles, because the side angle inequality theorem says that the largest or smallest side of a triangle is across from the largest or smallest, depending on which one you're looking for at, angle. So the largest side's across from the largest angle, the smallest side's across from the smallest angle, and then of course the middle is across from the middle. So it means you can look at a triangle like this and you can put these sides, you can tell which one's the biggest side. Since 66 is my biggest angle, B is the biggest side. So B is my biggest side. Since 55 is the smallest angle, A is the smallest side. So A has to be the smallest side, which means that side C is in the middle. Now, I don't know what the lengths of those sides are, but just because I can tell which one's across from the big angle, it works the other way around, okay? The last fact that we want to talk about with triangles before I let you go on this one and you'll come in tomorrow. The centroid. We already talked about the centroid. We said that the centroid is the concurrent point of the three medians of a triangle. And in the honors classes, we actually talked about what that centroid does. We said that that centroid divides the median into a 2-to-1 ratio, which means that this side here is always twice that side. This will always be twice that side. And this will be always twice, why don't I put a 3? Always twice that side. The larger side is always close to the vertex. The shorter side is the other piece. But that's always going to work out that way, okay, every single time, because these are medians. How do I know they're medians? Because I see they're bisecting this side. Okay, so that's what you look for. If I bisect the side and come from a vertex, that's going to make it a median. So the three medians given by centroid, and it bisects the sides it doesn't bisect, it cuts the sides in a 2-to-1 ratio, which allows us to solve this kind of problem. So real quickly, first see if you can set up an equation to solve for x. Okay, so the equation you probably set up, this side has to be twice that side. So it takes 2 of the 2x minus 1. So you could set that equation up. Or you could do, another way you could do it is I could do half of the 3x plus 6 equals 2x minus 1. So either of these equations would work, okay? This one's probably easier because it's easier to multiply by 2 than to multiply by a half. Now, go ahead and solve for x. Using either one of those equations, solve for x. So hopefully your algebra kicked in now. And let's see if I subtract 3x on both sides, add 2 to both sides, x is 8. Okay? So that's an easy way to solve for these. Can I get y? Not really, because I'm not given any information here, and we don't know anything else. So I'm not even asking you to look for y. That's just thrown in there to confuse you. So tomorrow you're going to come into class, you're going to have a Delta Math to work on, and it's going to review problems from all of this work. Okay? Good work. Enjoy your weekend. I'll see you Monday.